Yeah, good evening everyone. I'm Sheetal and today we are going to have an introduction to data structure using C, right? Let us start with the session. So let us start with data structure. What are data structure? We will be discussing in this session what are data structure and about arrays. One of the data structure I'm going to tell you one example of arrays in one dimension and in two dimension, right? So let us begin with the session. First of all, we need to understand what is data structure, right? From the base, what is data structure? Data structure is a structure which is storing some data, which is storing some information, right? So what are the clever ways? What are the efficient ways, right? What are the range of methods we have to organize the information in order to enable efficient computation, right? So we need to understand what is clever. Clever means we have range of techniques, we have range of values, we have range of methods. We need to select those methods which are efficient, which are faster, which is going to give us accurate result and fastly. It efficiently compute the results as well. So let us see, there are number of techniques, there are number of algorithms through which we can solve our problem and efficiently, right? Let us begin with the session. First of all, you need to understand what is data structure. A scheme for organizing related pieces of information. There are thousand records. How you need to organize? What is the scheme? What is the method? What is the technique? How to organize it? How to save it in the memory? How to store it in the memory? What is the way? The way of organizing, the method of organizing, the scheme of organizing is data structure, right? For example, you have pieces of information, right? You store somewhere, right? And what are the ways, what are the efficient ways to save your memory, right? So there are number of data structures. The most appropriate one which is efficient for saving the memory, for efficiently calculating the results, computation also, that is selected, right? Typically describes the operations which can be performed on the data and or how data are organized to support those operations and how we are basically manipulating those data structures. Can we, if we are saving 100 records, can we delete them? Can we add them? Can we pop some values? Can we push some values? So what are those? These are operations that can be performed on those data structures, right? So from this part, we need to make us mind clear the way to organize the data is data structure, how to save the data, how to perform different operations on data, that is what? That is manipulations on data that can be done through operations on data structures, right? So if I'm going to ask, like, you have one list of records, right? So list is again one structure where you are storing some data, right? Now if I have added 10 records, right, I am having 10 records, I want to add some records, so these are the adding. Or if I want to delete some records, this is deleting. So these are the operations that can be performed on those data structures, right? So these are the basic terms. When you go through the about data structure, you should know about the basic terminologies that are used in data structure, right? The first is abstract data type. You have different data types in any programming language, whether it is C, whether it is C++, whether it is Python, you have abstract data types. What are those? Mathematical description of an object with a set of operations on the object. So you have an object, you can perform operations on the objects as well. So useful building block is that ADT, right? Second is algorithm. Now what is algorithm? You have to do something. Suppose I want to make a cup of tea. So there are different steps to perform that, to make a cup of tea. I may be taking a pan, then I'm putting the water into it, then I'm adding the tea leaves, then I'm adding the sugar, then I'm adding the milk, then later on I'm going to boil that tea, and later I am going to strain that part using a strainer, right? And then I am having a cup of tea. So the whole process, the step by step process, what is that? That is an algorithm. That is called algorithm, right? In simple example I have told you, right? A high level language that is independent description of a step by step process for doing anything. It could be making a tea, it could be adding two numbers, it could be multiplication of two numbers, it could be anything, right? When you have a step by step process, you cannot say I have a cup of hot tea without boiling it. Can you do it? No. Why? Because you need to follow some steps to have a hot cup of tea. Once you boil it, then only you will get a hot cup of tea. So there are certain steps, there are certain statements in program to be written to get the output. Now data structure, I have already told you, a specific family of algorithms for implementing an abstract data type. Now we can conclude that ADT is used and an algorithm is written to make a data structure, right? To implement this thing, right? Implementation of as data structure, that could be in C, that could be in C++ also. It is not like only single language is used. It could be any specific language you may use it to implement the concepts of data structures, right? So what we have learned from this, what are data types? We will be learning into the detail also. What are algorithms? What are algorithms? Algorithms are the series of steps or step-by-step process to perform specific task, right? What is data structure? And method to organize the information using ADT and algorithm. ADT is what? Abstract data type. Data type is what? Whatever mathematical description of an object. If it is a string, it would be a characters. If it would be a number, integers. If it would be a decimal point numbers, floating. So you need to define the data type of your data, of your information, right? Suppose taking an example of this, I am saving my phone number. It could be what type of data type you will maintain for saving a number, for saving a phone number. It could be numbers, but it should be enclosed in a string. You cannot perform manipulations on that data type, right? You cannot do this thing to add 2 to this phone number. No, you cannot manipulate those phone numbers, right? Whereas when we have marks are numbers, actually are integer values which can be manipulated. Manipulated means you can add 2, you can multiply with that value also, you can get output. Whereas like you have pen numbers should be defined as a what? Alphanumeric type of data, where you have characters also, and in that you have numbers also, right? So there are different data types for which we will be using. Like string, I am going to define for that. If you are going to save your name, so name does not include any numbers. It should not be integers, it should be string. So you have number of characters A, B, C, D, E, and then you are going to define it as a string, right? And how you are going to save it? With the help of data structures, right? Let us move to the first data structure, that are arrays. Most of you have heard about arrays. What are arrays? How it is maintained? How we save it in the memory? I don't know. I like some students are facing problem in like, ma'am, how to make an array? How to manipulate the array? Why array is homogeneous only? Why it is not heterogeneous? What do you mean by heterogeneous? What do you mean by homogeneous? Let's understand this thing. right? A list of values with the same data type. This is the same data type means it should be homogeneous. Homogeneous means it should include only numbers, right? So same data type. You may take any type of data, right? So same data type that are stored using a single group name, that is array name, right? Journal array declaration statement. What is the syntax? How to define it? So you need to define the data type. It could be integer, it could be string, it could be character, it could be float. Whatever you want to define it as an array. So define the data type, space, then give the array name. Don't give the irrelevant names A, B, C, D like this. Give a relevant name to the array and then number of items in the array, right? For example, I'm taking a example of my house, right? If I'm defining it as a data structure and if I'm defining it as a house as an array name, what are the number of items? The number of rooms in the house, right? So suppose I am taking this room as one, another room as one, another room as one. How many rooms are there? The total number of that should be mentioned here, right? And how it is indexed, I would be telling you in later slides, right? So the syntax, the most important part is data type, the name of the array, and the size of the array. How many rooms, how many items should be there in your array? The number of items must be specified before declaring the array. Why it is specified? You may say, like if I want to change the size of an array and I have written 1,000 line of code, so I need to go move to each and every, because I may be using in later program the subscript of that part, right? So how to define that? Constant integer size is equal to 100. Suppose I am taking example of a house or a hotel. In that hotel, it is going to give you 100 rooms in that hotel. So the size is defined as like this. 100, the size is 100. What is the array name? That is ARR. So you define the data type float, then array name, and then in your square brackets you need to define the size of the array. You may take it as a like this variable you have defined कि integer type का you have defined one variable, that is 100, and then you have that variable is used as a subscript of that array. And later, like how to define it, how to use this array, we will be going into the detail of this. Let's take an example. First of all, understand this thing, how it is defined. Like suppose I have given ARR size 100, right? So let us move to this. Individual element items of the array can be accessed by specifying the name of the array and the elements index. Now what is element index? Let me tell you what is element index. Array, whenever we define an array, like this array has these number of items, right? You start from the starting of the array and it should be homogeneous. Homogeneous means if I am storing the data type is integer, so I may be storing only the numbers only. I cannot put it the string or characters into that, right? And it should be homogeneous, one by one it is located. Like I have given the example of your house, right? Like you have one room, then behind that one room, then behind that one room, then next to that is one room. So this is how array is also maintained. It is not like that ki one room is here and somewhere else some room is there. No, it is in a one direction. Starting with the first location of the array is called the subscript. You may say the subscript of first element, the index of first element is called array name and it starts with 0. Right? So array and the subscript 0. Then move to the next element, move to the next index 1. Then move to the next index 2. Then move to the next index 3 and so on until you reaches the total number of size. So whenever you define the array, like if I have defined 100 elements, it is basically in the memory 100 spaces. These number of spaces are saved. Right? So if I am going, if like suppose array 6 I have not used, any anything I have not saved. So it's wastage of memory. Something garbage is there. So this is what? This is wastage of memory. I need to use, I have shown you the first slide, efficient computation, clever methods to be used. Now, if I am taking the 100 spaces of my memory, I may be using some clever methods. No. So these are some disadvantages of array, right? Let's start with this. Let's see the syntax. The array name ARR identifies the starting location of the array. Now in the starting location, I am pointing like a yellow line is pointing to the first element, first item of the array, that is denoted by the index, that is ARR 0. The next index would be ARR 1. The next index would be 2 and so on until you reaches the total number of signs. So it allocates in the memory like this only, in one order and homogeneous data items. Let's see one more example. Suppose we have taken array, 1D array, one dimension array. Arrays can be initialized during their declaration. So you may be confused, what is declaration, what is defining of array. So there are different ways to define an array. There are different things to define this. What is that basically? Let's see. I have defined the array name as ARR and the data type is integer, right? And it has how many elements? It has 5 elements, right? So 5 elements it has: 98, 87, 92, 79 and 85, right? So how it is stored? At the time of initialization, at the same time I have given the values also. Right, in the previous slide, like this, I have not given any. It is just initialized. It is only declared. Right, float array size. I have not given any values to this array. Whereas in this part, I have initialized also, and during the time of declaration, whenever we declare that particular array, we initialize with some values also. So I initialize with values, that is 98, 87, 92, 79 and 85. Right. Now let us move to the next example. We are taking the data set, that is character, right? That is a string, and that is the, what's their name? That is quotes. And this quotes has a number of characters because I have taken the data type as char. Right. So the first character is this, the second index is this, the third index is this. So whenever we, how to basically segregate, how you will define this, the ways are also different. Like in numbers, there is no need to enclose it with the quotes. Whereas when we are defining the characters, it should be enclosed in quotes. Right. So you may say this is the difference when we define our character. Right, and when we define a number, otherwise it would be giving error if I am not going to define the this character in quotes, right? But whereas if you put these numbers in quotes, it will become string only, it will become character only, right? So whenever, it's very much important, whenever you define the data types, you need to define their data type and follow the particular syntax also, right? Yes. So this is how it is stored. Okay. Code 0 S. Code 1 A. Then M. Then P. Then L. Then E. Now what is this /0? This is null. That indicates the end of the string. This is /0, or you may write it in a capital letters NULL. That is null. Null means end of the string. It should be inserted at the end of the string to make the memory understand like this is the end of the string. There is nothing after this. And it is there for each string. It is not like for here only I have written. Whenever you define characters, whenever you want to end the string or a character type of array, you need to mention the last, yes, the last index of the character array should be null value, right? Again I am repeating, integer mein there is no need to add null or something else in integer data type. Just write the numbers, just write the values, it is over, right? Whereas when we have strings, we need to have the elements like sample s is index 0, then a has index 1, then then m has index 2, and then p has index 3, and so on. But what is this null? E के बाद तो कोई element ही नहीं है. There is no element after this E. So what is this? So this is the null value that tells you about the end of this string, right? So this is how we define a one dimension array, how we initialize the arrays, right? First of all, we have understood what are arrays, how to declare the array. Now the third step is how to initialize the array with some values, and at the same time we are talking about data structures, how it is saved in memory. It is like in a continuous way. You can see on my screen, it is continuously, it is saved, right? And one by one it is saved. The second thing is index is maintained. If you want to access any element, suppose I want to print codes 4, it is going to print the value that is L. So this is how indexing is also going to be used, right? So these are some data structures. What are these? These are some data structures which are maintained. Let's see the syntax of two-dimension array as well. Now we have understood the one dimension array. We have just check out the size of the array is 5. In the second character, you need not have to mention, you may take it like this. So whenever you define it as 5, that is a single one dimension array. There is only one dimension in the array. What about if we have rows and columns, right? So we may be taking it as two-dimension array. So in two-dimension arrays, a two-dimension array consists of both rows and columns of elements, right? How to declare it? What is the syntax? Let's see. Data type, same. Array name, space, array name. Now whenever you write a single dimension array, just write down the size. Whereas when we have double dimension array or two dimension array, we can write it as number of rows, then again one square bracket number of columns, right? Then semicolon to end the line, right? This is how we are going to write it. So the general declaration for 2D array is number of rows and number of columns should be mentioned, and so on also. Suppose I have n dimension array. So whatever n dimensions are 4, 5, 6, so you have to add like this only, right? So I am talking about 1 and 2 dimensions in this session. Let's take the example how to write it. How to take it as this. The number of rows and the number of columns must be specified before declaring the array, as I told you earlier also. You need to define the size of what will be the subscript for rows and what will be the subscript size of columns. So now next thing is, when you declare the array, it should be mentioned like what is the size of rows and what is the size of columns. So I am taking it as data type space array name. So I have given the array name as ARR2D, then rows and then columns, right? So this is how two-dimension arrays are defined. After this, once we have defined this, individual elements of the array can be accessed. I told you how to access the index of the array. I told you about how to access a particular item from the array by using indexing. So individual elements of the array can be accessed by specifying the name of the array and the elements row. Suppose and column indices. Now what are indexes in this? Suppose I want to access the row is 3rd and column is 5. So the syntax would be like this. This is the index of that particular value. It is not the value. It is the index of that particular value. That is ARR 2D. The row index is 3 and the column is 5. How it is written, right? Anything that is to be written that as a syntax, like if I want to access to second column of second row, right? So what I am going to write is ARR 2D 2, right? So let's revise the concepts. The first, we have understood about what are data structures, how to manage the data, how to organize the data, that is using data structures. Then ADT, abstract data types. What are data types? Integers, characters. Why we take integers? For number values. Why we take characters? For string or alphabets. Then we have floating type of values also. Decimal point of values. Then what is that? Data type, that is float. In later chapters, we will be talking about like what are the data types of, what are data types, how we are going to use it. Now, after this, I have started with a single data structure, that is what? That is array. Now, I told you array is a homogeneous collection of data. What do you mean by homogeneous? Is Let me tell you what you mean by homogeneous. In a array that is ARR 5, have you seen, are you able to see that there is any character? No. There are only numbers in this particular array. In the second array, that is codes, have you seen any number in this? No. They all are characters. So, this means the same type of data is to be stored using array. It should not be a heterogeneous or different kind of characters in the array, right? Or in the first part, I would say 98 S, 92 B. Like this I can store? No, because array contains the same data type. So if I am going to define it as an integer, it should contain only numbers. If I am going to define it as a character, it should contain only characters value. It should not contain any floating point numbers, means your decimal point numbers, or any digits, right? So this is how we basically defined one dimension array and how we define two dimension array, right? Same as with this only also, when we have to define the rows and columns, the same structure is followed. The same thing is followed. I would be giving more examples on this in the later chapters. Let me tell you about this. Arrays can be initialized during their declaration. Like how, what is the size of an array? 3 into 3. Now 3 elements, first row, 3 elements, second row, 3 elements, third row. This is how it is controlled. And why there are 3 values? Because we have 3 columns, 98, 87, 92, 79, 85, 19. So these are the 3 values. This is how we basically takes an example for a 2D array. The compiler fills the array row by row. Elements are stored in the memory in the same order. You cannot change the order because I told you it's a homogeneous collection and you cannot jump from this room to the outside room. It should be some index are followed, so you need to follow the index, and as when you are following some index, that means you are following the values also. The same, at this index this value is saved, at this index this value is saved, at this index this value would be saved, right? So in today's session we have learned about one dimension array, two dimension array, right? In the later sections we will be learning about more data structures which are efficient and which are saving the memory as well, because I told you clever methods and efficient computation, right? So catch you later.